Kinetic energy. We started by looking at our data from last Friday. The proportionalities that you should have found were that v squared was proportional to kinetic energy, or that v was proportional to the square root of kinetic energy. You also should have found a direct proportionality between mass and kinetic energy. Alright, using the data from your lab, when we combined those two proportionalities, we got that k was proportional to mass and velocity squared. So mass times velocity squared became the right-hand side of our expression. Then you graphed the data using the instructions on your lab sheet. Now, this meant that the quantity we calculated, the right-hand side, mv squared, was along the x-axis, and kinetic energy was along the y-axis. Given those two things, and the combination of our proportionalities, that means that the slope of the resulting line was going to give us the coefficient to go in our equation. You found the slope. Lo and behold, it was 1/2. And that's what pretty much everybody got, even though you all had different data. So what did that make our equation? Well, let's talk about it. Kinetic energy is something you've probably seen before in science class. When we studied kinematics, we were putting numbers to motion. People who study kinesiology are studying bodies in motion. So it shouldn't be any surprise that the word kinetic has something to do with, hey, motion. So kinetic energy is the energy associated with something's motion. Energy is a scalar. In this class, AP Physics 1, energy will not be a negative number. Change in energy, as we'll talk about later this week, can be a negative number, but that's only if you go from some set amount of energy to less energy in a system. And we'll see that in action later. The units for kinetic energy are joules. We abbreviate that as a capital J. And here's our equation that we figured out. The variable for kinetic energy is a capital K. This is exactly as it's written on your AP equation sheet. As a hint, all your energy variables are going to be capital letters. Okay, this shows sample problem 1 as I marked it up in 4th period. Okay, the givens in this problem are my mass and my velocity. Even though it says speed, it's really just giving me the magnitude of the velocity. Since we're going to square the velocity anyway, for these types of problems, it won't actually matter if my velocity is positive or negative. Okay, my unknown is K, the kinetic energy, and then there's my equation with numbers plugged in. The 144 is 12 squared. Okay, now this one, if you put it in scientific notation, it wouldn't be wrong. Don't convert it to kilojoules in this class. Leave it in joules. Okay, sample problem 2. This one's a little more complicated because we have to solve for the mass using algebra in our equation, and we've got scientific notation. This one, you've got to leave it in scientific notation because I'm not counting 30 zeros. Also, don't forget your SI unit for mass is kilograms here. By the way, that answer is pretty much the actual mass of an electron. Okay, your homework is to watch this video and to take the Moodle quiz in section 4 called Kinetic Energy Video Quiz. Come ready to talk about collisions and the patterns we saw in the lab tomorrow. You'll get your labs back at the beginning of class. Your exit ticket was to use the formula for kinetic energy and prove that a joule is the same as the composite unit kilograms times meter squared over second squared. If you have any questions about this, please email me.